Good morning, Mr. Ferenzi here, and Bones. And today what we're going to do is we're going to review some of the different kinds of lab equipment that you used last year in science class, just to refresh in your minds because we will be using this equipment going forward. If you'd like to do any work on a scrap piece of paper, you're more than welcome to, but we are also uploading a worksheet for you to follow along with us if you, that you could print out at home if you'd like to do it on a worksheet more formally, okay? We're going to start with how to use a triple beam balance. A triple beam balance is used to measure the mass of an object. Mass is how much matter is in the object, how many molecules are in there, okay? And we do it using a triple beam balance. So the first thing we're going to measure is a wooden block, okay? What you do with the wooden block is you simply put the wooden block on the pan of the triple beam balance. Now these things here are called riders. We're going to slide the riders until the triple beam balance, okay, slides down and the arm of it matches the little white line over here. So I slid this rider all the way over and nothing happened. So I'm going to slide it all the way back. Now I'm going to take my next rider and slide it over. There are notches in here. You can hear them. Okay, so what we're going to do is we're going to slide the second biggest rider over as far as we can. Okay. But the arm went down too far. These lines don't match up. So we have to go back one notch. But now it's too high. What do? I go back to the smaller rider. I slide it over until the lines on my arm of the triple beam balance match the line designated over here. Now, it is impressive that I can do it upside down. I know, you can hold your applause. All right. Go on over a little bit more. And we're now pretty close to lined up. Now, how do I get the mass of this block? Simple. Add up the two riders. So I look at our big rider and I see it's 50 grams. I look at our second rider, I see it's 9/10 of a gram. So what we would do is we would take, for the mass of the block, we would take 50
4 monitors, please come to Mr. O'Neill's
plus
office.
9
4 6 hours,
equals
4 monitors, please come to Mr. O'Neill's office.
59.0 grams. Don't you love announcements in the middle of a lesson? Moving on. Okay. Mass is always measured in grams, and that's measured with a little g. And for our purposes in this class, we're always going to measure everything going to the 10th place. Even if it's a 0.0, you need to put the 10th place, you need to put the 0 in there as a placeholder. So that's how you would do a wooden block and use the triple beam balance. We could also do it using the screw. We will reset the riders. Take the screw, put it on the pan. This is obviously has a lot more mass, so I'm just going to start with the larger rider this time. Slide it over in the notches, went too far. Going back more. Now it's not enough, so I'm going to slide the smallest rider over. Until the lines match up here, okay? And I simply add the riders again. This is 30 for this one and 9. So even in my estimation, I was incorrect. I thought this one had a lot more mass and I was incorrect. So I would do 30 plus 9 equals 39.0 grams. Okay, simple as that. That's just a quick review on how to use a triple beam balance to find the mass of an object. The second thing we're going to do, I'm going to reset my riders, is we are going to measure the volume of a regularly shaped object. Now, what's a regularly shaped object? Regularly shaped object is like a block. This is irregularly shaped. There's not a length, width, and a height. This is regular shaped. There is a length, width, and height. So just like in math class, we're simply going to measure the length, width, and height of the object using a ruler in centimeters. We're always using the metric system here in science. And what we're going to do, so we don't mess up what our length, width, and height are, is we are going to take our finger, put it on a corner of the block, and measure the 3 sides that come from there. This side here, and this side here. Sometimes when the sides look so similar, we accidentally measure the same side twice. So this is a little trick in order to not let that happen, okay? So I'm gonna take my ruler, measuring in centimeters. I'm gonna measure the small side. I see that it is 3.5 centimeters. Let me write that down. And I'm also going to write my formula up here. Length times width times height. We're going to multiply 3.5 centimeters times 6. And finally, our last side, which is 5.5. Okay. Now we just have to use a calculator in order to calculate the mass or the volume of an object. So I'm going to take out my calculator. I'm simply going to plug in 3.5 times 6.0 times 5.5, enter. I get volume equals 115.5 centimeters cubed. Okay, so volume of a regularly shaped object, when we're measuring in centimeters, because we're multiplying three things together, is centimeters cubed. Now, when we find the volume of an irregularly shaped object, we do something a little different because there's not a length, width, and height to measure. What we're going to do is we're going to use a graduated cylinder to find the volume of this. So what I like to do is I like to take some water and I fill it up to the 50 milliliter mark or the halfway mark. That's my starting water level. You don't necessarily have to fill it up to 50 milliliters. I just like starting at a nice even number, okay? It doesn't matter if it's 20, 30, 40, 80, it's all good. All right. Now, in order to make sure that it's properly measured, I'm going to get down to eye level and I'm going to look at the meniscus. That's the bottom of the water, okay? That goes across the graduated cylinder, and I see the bottom of the water is at 50 milliliters. That is my starting volume of water. Now, because we're using a graduated cylinder, this time we're measuring in milliliters, not centimeters cubed. Now, very carefully, and try not to splash out any water, what we're going to do is we're going to take our object, tilt our graduated cylinder, and very gently slide it in. Now, what's going to happen? The water level is going to go up, okay? That's why it's important to try not to let water splash out and go all over the place, because that's going to affect your results. So now I'm going to go ahead and take a look, and I see the water level went up to 57. 57 was the end, 50 was the start. All we gotta do is subtract. Easy. 57.0 milliliters minus 50 leaves us with 7 0/10 milliliters. Always rounding to the 10th place and always adding a label. So these are three of the skills that you guys worked with last year. The last one that I want to go over is how to calculate the density of an object, okay? Now, in order to calculate the density of an object, we need to know the mass of the object and the volume of the object. And we simply plug it into a formula. Purple. The formula is density equals mass divided by volume. So what we're going to do for our block, I'm just going to put a little B there for block, BL. I'm going to plug in my numbers for density. My block mass was 59.0. You okay, Bones? You understand? Do you have any questions, Bones? No questions? You good? All right, good talk. 59.0 divided by, what was our volume for our block? 115.5. centimeters cubed, which gives us an answer of, take our calculator, you don't have to do any of this by hand, 59.0 divided by 115.5, and I get an answer of 0.5. Now it's 0.5108225. It's a whole lot of numbers, but now we're going to use our rounding skills and we're going to stop it at the 10th place. So our answer here is 0.5 grams from here per centimeters cubed. And we're going to come back to that answer in a second. For the other object that we use, the screw, okay, we're going to do the same thing. Density equals mass divided by volume. Our mass was 39.0 grams divided by our volume, 7.0 milliliters, and we get an answer of, love calculators, 39 divided by 7, 5.5714285. Again, you don't need all of those numbers. Cut it off and round to the 10th place, and we end up at 5.6 grams per milliliter. Notice I'm using the grams and the milliliter label now. So it's a little different in the two different labels that you can use. Now this tells us something about the object. This tells us whether or not it will float or sink in water, okay? So if you remember correctly, Bones, do you remember? What is the density of water? I'll give you a second. What? Huh? It's 1. That's right. The density of water is 1.0. So what does that mean? That means if an object has a density less than 1, it should float in water. Let's test it out. Our block has a density less than 1. I hope this floats. It floats. Let's check our screw. I'm going to dump it out in here very gently, not to break any glass. This has a density of 5.6. If the density of water is 1, this should, Bones? That's right, it should sink. Let's see if we did our experiment correctly. It sinks. All right, I hope you enjoyed a little bit of review. Make sure you go on your Google form now and answer a couple multiple choice questions on what you just watched, and have a great day, guys.